Today's lesson is about using a calculator to do elimination. You have these instructions. You'll need a TI-84 calculator or TI-83. And we'll follow these steps for solving a matrix, which is a system of linear equations if I take out some of the symbols. So we'll write that for big ideas. The calculator will be doing elimination to solve a linear system So elimination rules apply. You'll have to have standard form. And we will remove, well, standard form for two variables is ax plus by equals c. But since the calculator will be solving, we can put a more complicated system in. We will have some three variable system, ax plus by plus cz equals d. We'll take all of the symbols out. We'll only use numbers. If I have two equations, two variables, two variables, then I'll have a 2 by 3 matrix. If I have three equations, and I'm using three variables, then I'll have a 3 by 4. And we'll do some examples of each of those below. One thing that will be important when I use elimination in the calculator is that I don't want to have any missing terms. Here, I'm missing an x. There isn't one. If you're missing a term, then you have 0 x's. I just want to make sure that the x and y and what it's equal to are all represented. So I will write this first equation in standard form as 0x minus 4y equals 1. Also, I don't have a coefficient for my second equation. There's an invisible 1 here that we don't usually write, but I want to include that. 1x minus 5y equals negative 3. The reason is, I take all the symbols out. I'm only going to write our system with numbers, so I want to make sure all the numbers are represented. To write this as a matrix, my first equation is 0, negative 4, 1. My second equation is 1, negative 5, negative 3. That's what we would type into the calculator. With this second example, neither one of these equations is in standard form, so I need to do some rearranging. My first equation, x and y are on the same side of the equal sign, but they're in the wrong order. So I need to write that as negative 5x minus 1y equals negative 7. For my second equation, x and y are on opposite sides of the equal sign. If I move this 7x to the left side, then I'm left with nothing on the right side. So my equation in standard form would be negative 7x plus 8y equals 0. As a matrix, I'll write this system as negative 5, negative 1, negative 7, negative 7, 8, 0. This last system is not in standard form. Hit pause, write it in standard form, write the system as a matrix, and then turn your video back on so that you can check yourself. I finished rewriting my equations in standard form and I wrote it as a matrix. Each of these examples I would list as a 2 by 3 matrix because there are 2 equations, so I have 2 rows, and I have 3 columns of numbers. So each of these is a 2 by 3. The next set of equations we will write as a matrix are 3 equation systems. I'll have 3 variables for my 3 equations. When I take the symbols out, I'll have 3 rows of numbers and 4 columns. This first equation is already in standard form. So no rewriting is necessary. My second equation is missing x and not in standard form, so I need to rearrange the order. My new equation 2 will be 0x minus 4y minus 7z equals 5. I also need to rearrange my third equation and put the 7x with the y and the z terms. My new equation would be negative 7x plus 8y plus 9z equals 0. To write this as a matrix, I only write the numbers 5, 3, 7, negative 3, 0, negative 4, negative 7, 5, negative 7, 8, 9, 0. And I put this in this big set of square brackets like what we were using for domain and range. Sometimes you'll see a line here. That's where the equal goes. This is the x column, the y column, the z column, and what each constant would be. This system needs to be rearranged so that it's in standard form. Please rearrange that now. Pause your video and turn it back on when you've fixed it. Here's my system. It depends on which way you move your terms when you're moving to standard form, whether your system will look exactly like this or not. You may have moved in different directions, and that essentially would have created different signs here or on any of them. If you had opposite signs all the way through an equation, that's all right. That's equivalent. As with elimination, you can multiply an equation by any number. So either of these solutions would be accurate. At the bottom of your notes sheet, there is an error. If you write these equations in standard form, you might write 4x plus y is equal to 12. That's this top equation. And 2x minus 3y equals negative 4. Here, because I moved the y to the right side to be with the x, my signs are different from the signs here. That's not the error. The error is that the columns are reversed on the second equation. This is an x coefficient. This is a y coefficient. So to write this system correctly as a matrix, it should look like 4, 1, 12, negative 2, 3, 4. If I had written the way I had rearranged mine, I would have 2 and negative 3 and negative 4. But the only difference there is a negative sign all the way through.